In this lecture, we're going to cover section P5, which is factoring polynomials. So factoring is when we rewrite a polynomial as a product. So whenever we have a sum of monomials, that's called a polynomial. So we can have binomials, trinomials, we can have polynomials with 4 terms. So when we want to rewrite a polynomial as a product, we call that factoring. And factoring could be as simple as rewriting a monomial as a product. So for example, if I wanted to factor the number 12, I can rewrite 12 as a product of 6 and 2, right? 6 times 2 is 12. I could write it as 4 times 3, since 4 times 3 is also 12. So that's very simple, a very simple example. We're going to be factoring polynomial expressions that have 2 terms, 3 terms, 4 terms. And when we factor a polynomial, we want to factor it completely. And we're going to do examples. I think the most common factoring method that a lot of you think of when it's time to factor is factoring out the greatest common factor. And we usually call the greatest common factor the GCF. And it's an expression of the highest degree that divides each term of the polynomial. So what does that mean? Well, let's look at an example. So what if I said to factor 2x plus 4? That's a polynomial with 2 terms. It's a binomial. So we want to rewrite that as a product, as multiplication, right? Because that's what we do when we factor. So if I look at both of these terms, the greatest common factor, so the factor that's common to both of these expression, that's the greatest, is 2, right? Because 2x is divisible by 2 and so is 4. So my GCF of 2 is going to be one of the factors. Now I have to figure out what the other factor is in my product. And the way we get the other factor after we factor out the GCF is we take each term of the polynomial and we divide it by the GCF. So we take 2x and we divide it by the GCF of 2, and 2x divided by 2 is x. And then we're going to take positive 4 and divide it by the GCF of 2, and we get positive 2. So I'm going to have x plus 2. And the way we check to see that we factored correctly is we distribute. We actually multiply out, and we should get the polynomial expression that we started with. So let's check. So 2 times x plus 2, right? If I distribute, we're going to get 2x plus 4, which is what we started with. So let's look at some examples. So example 17 says factor. So A, we have 10x to the third minus 4x squared. So we have a binomial, and when I look at those two terms, I see between a 10 and a 4 that the greatest common factor is going to be a 2, right? 10 and 4 are both divisible by 2. And then we have an x to the third and an x squared, right? So we have like terms there. We have 2x terms, and an x squared is going to be the greatest common factor because both an x to the third and an x squared are divisible by x squared. So my GCF in this case, or my greatest common factor, is going to be equal to 2x squared. So I'm going to factor out the 2x squared. So I'm going to have 2x squared as my first factor. And now my other factor is going to be, what we're going to get after we divide the 10x to the third minus 4x squared by 2x squared. So 10x to the third divided by 2x squared, well, 10 divided by 2 is 5. And then x to the third divided by x squared is x. And now we're going to take the negative 4x squared and divide it by the GCF of 2x squared. And negative 4 divided by 2 is negative 2. And x squared divided by x squared is 1. So in factored form, I'm going to have 2x squared times 5x minus 2. And if I were to redistribute the 2x squared by multiplication, I'd end up with 10x to the third minus 4x squared. So now let's look at B. So I'm looking at my two expressions here. I have a 2x times x minus 7, and then we have a 3 times x minus 7. So my greatest common factor, right, the factor that's common to both of these expressions is the x minus 7. So in this case, the GCF is x minus 7. So I'm gonna factor out the x minus 7, and then I'm gonna divide each one of my expressions by x minus 7. So I'll do the work off to the side here in a different color so you could see. So I'm gonna take 2x times x minus 7 and divide it by x minus 7. And I'm just gonna end up with 2x. And now I'm going to take the 3 times x minus 7. And I'm going to divide that by my GCF of x minus 7. And I'm going to get positive 3. So I'm going to get 2x plus 3 as my other factor. So in factored form, my result is x minus 7 times 2x plus 3. So I think factoring out a GCF should be a review for most of you. We could do one more example here. Here, let me make up another example. So what if I had, I don't know, let's say 6y squared and then plus 12y to the fourth, let's say. So I want to factor this. So my GCF is going to be between the 6 and the 12, I could factor out a 6. And then between the y squared and y to the fourth, they have a y squared in common because both a y squared and y to the fourth are divisible by y squared. So 6y squared is going to be my greatest common factor. So now I could factor it out. So we're going to have 6y squared. And now take each term of my polynomial and divide it by 6y squared. So 6y squared divided by 6y squared is 1. And then now take the 12y to the fourth and divide it by 6y squared. And 12 divided by 6 is 2, positive 2. And y to the fourth divided by y squared is y squared. So my factored form is going to be 6y squared times 1 plus 2y squared. Another method that we see when we factor is factoring by grouping. So sometimes polynomials only have a greatest common factor of 1. But if we can group terms, it still may be possible to factor. And we're going to factor by grouping when we have a polynomial that has 4 terms. So look at example 18. So I have this polynomial here that has 4 terms. And if I were to try to factor out a GCF, it would just be 1, because think there's a 1 in front of the x to the third. So between the 1, the 5, the 2, and the 10, the only common factor is 1. And not all these terms have an x. So there's really nothing to factor out except for a 1, which is not going to change what this sum looks like. But there's 4 terms here. So what we can try when I have a polynomial with 4 terms is grouping the first 2 terms together and then grouping the second terms together. So kind of think about splitting the polynomial in half. So let's look at the x to the third plus 5x squared. And then we'll look at the negative 2x minus 10. And it's not that I'm factoring it separately. It's just we're going to read from left to right and look at the first group first and then the second group second. So we could think of this as kind of two separate sides here. So then we have a minus 2x minus 10. So just keep the appropriate sign with the third term. So that negative has to go along with the 2x. So let's look at the first group. I have an x to the third plus 5x squared. My common factor there, my greatest common factor is an x squared. So I'm going to factor this binomial here by factoring out an x squared. Now divide each term by x squared. So x to the third divided by x squared is x. And now take 5x squared divided by x squared, and we're going to get positive 5. So I factored the first group. Now let's look at the second group. I have a negative 2x minus 10. I see there's a common factor of 2 between the 2x and the 10. But you have to pay attention to sign. You see how this leading coefficient for this group is negative? So whenever the leading coefficient's negative and we're going to factor out a common factor, make it negative. So I'm going to factor out a negative 2. And notice I'm continuing on in the same expression as the first part, as the first group that I factored, because this is still one problem. So I factored out the negative 2. Now divide each term by negative 2. So negative 2x divided by negative 2 is positive x, and negative 10 divided by negative 2 is a positive 5. So now that I factored by grouping, we can see, and I'll change my color to red, that we have a common factor, right? It actually looks similar to the problem that we did up here in part B, right? So we have this x plus 5 that's common to both of these products in this expression. So I'm going to factor out the x plus 5. And if I divide x squared times x plus 5 by x plus 5, all I'm going to be left with is x squared. And now take the negative 2 times x plus 5, divide by x plus 5. So the x plus 5 and the x plus 5 is going to cancel to 1 or reduce to 1. And I'm going to be left with the minus 2. So in factored form, I'm going to have x plus 5 times x squared minus 2. And again, you could use your distributive property to check your answer. So let's factor one more by grouping. So let's look at B. So I have a polynomial here that has 4 terms, so let's split it in half. So group the first 2 terms. So I have 3x to the third minus 2x squared, and then I'm going to group those together, and then I have a negative 6x plus 4, which I'm going to group together. So let's factor the 3x to the third minus 2x squared. So my greatest common factor is going to be x squared, so I'm going to factor out an x squared. 3x to the third divided by x squared is going to be 3x. And then negative 2x squared divided by x squared is going to be a negative 2. Now from my second grouping, the negative 6x plus 4, the leading coefficient's negative, so I know I'm going to factor out something that's negative. And between a 6 and a 4, we could factor out a 2. So take negative 6x divided by negative 2, I'm going to get positive 3x. And now take positive 4 divided by negative 2, and I'm going to get negative 2. And we can see that now I have a common factor. So both of these expressions have or products have a common factor of 3x minus 2. So let's factor out the 3x minus 2. And when I divide each expression by 3x minus 2, right? The 3x minus 2s are going to reduce to 1. So I'm going to be left with x squared. Now divide the 2 times 3x minus 2 by 3x minus 2, and I'm going to be left with -2. So my factored form is going to be 3x minus 2 times x squared minus 2. And again, you can distribute in order to check your answer. So that's how we factor by grouping. We are going to have more examples later on where we have to factor by grouping. So we'll still do some more practice when we get to those. So let's look at another polynomial type. What if I have a trinomial? So a polynomial that has 3 terms and it's in the form x squared plus bx plus c. Now notice the leading coefficient on the x squared term is 1. So it's like we have 1x squared plus bx plus c. So whenever I have a trinomial in this form, we can factor it as follows. So we can write the factors as 2 binomials with the first term's x. Because the only way when I redistribute that I'm going to get an x squared is by multiplying x times x. So I know I'm going to have 2 binomials with the first term x. Now what we want to do is we want to find 2 numbers that multiply to c. So in example 19, c is the 40, but they have to add to b. So in this case, b is 13. Right? When we're in the form ax squared plus bx plus c. And then we would use the 2 numbers that we found in step 2 as the last terms of the factors. So let's factor example 19a, which is x squared plus 13x plus 40. So we're looking for 2 numbers that multiply to 40 but add to 13. So they have to multiply to c, add to b. So I'm thinking 8 times 5, right? 8 times 5 is 40, and 8 plus 5 is 13. So I'm going to have plus 8 and plus 5 for the last 2 terms of my factors. And you could have done it in the opposite order. You could have written x plus 5 times x plus 8. Order doesn't matter when we multiply. And again, to check your answer, you could multiply out, use FOIL for the x plus 8 times x plus 5, and we're going to get the original expression. So let's look at part B. So for part B, I want to factor x squared minus 4x minus 5. So if this is factorable, I need 2 numbers that multiply to -5, because -5 is c, and they have to add to b, which is -4. So let's think of 2 numbers that multiply to -5, but add to -4. So I'm thinking a 1 and 5 combo, but one has to be positive, one has to be negative. And when I add them, they have to add to -4. So I'm thinking a -5 and a +1, right? Because -5 times +1 is -5. And when I add a -5 and a +1, we get -4. So in factored form, we're going to have x minus 5 times x plus 1. And let's do one more in this form. So let's look at C. We still have another trinomial in the form x squared plus bx plus c. So if it was factorable, I would need to think of 2 numbers that multiply to c, which is 20, that add up to b, which is 6. So let's think. 1 times 20 is 20, but 1 and 20 would never add to 6. 2 times 10 is 20, but 2 and a 10 wouldn't add up to 6. We have 4 times 5 is 20, right? But a 4 and 5 combo, when I add them, is not going to add to 6. We also have, that's it actually. I covered all the factors, right? Because we did 4 times 5, and then 6, 7, 8, and 9 are not factors of 20. 10 is, but we already did the 10-2 combination. So since there's no factors, that multiply to 20 and add up to 6, we say that this polynomial is prime, which means it's not factorable. So if we have a polynomial that can't be factored, we call it prime. So now let's look at the trinomial where it almost looks the same, but instead of x squared plus bx plus c, we're going to have ax squared plus bx plus c, where a is not 1. So now we have to pay attention to what a is. So the way we're going to factor this is when we have a trinomial in this form, we're going to determine what the product of a times c is, because now we have to pay attention to a, not just c. So we're going to take the product of a times c, and we're going to determine what factors of a times c sum to b, and then we're going to ungroup the middle term, the bx, to become the sum of the factors that we found in step 2, and then we're going to factor by grouping. So I know that sounds like a lot, but once we do an example, it'll make more sense. So let's look at number 20. So for number 20, I have 8x squared minus 10x minus 3. So a is 8, b is negative 10, and c is negative 3. So what we're going to do is we're going to multiply a times c. So a times c is 8 times negative 3, which is negative 24. So now we need to think of two numbers that multiply to negative 24, but are going to add up to b, which is negative 10. So two numbers that multiply to negative 24 and are going to add up to b, which is negative 10. So I'm thinking it has to be negative when we multiply. So one's going to be positive, one's going to be negative. And what comes to mind is 12 times 2, because a 12-2 combo can add up to negative 10, right? If we get the signs right. So my factors are going to be a negative 12 and a positive 2, right? Negative 12 times 2 is negative 24, but negative 12 plus 2 is a negative 10. So this is what we're going to do. We're going to ungroup, just like I said up here in step 3, we're going to ungroup the middle term to be the sum of the factors that we found in step 2. So the two factors that I found are negative 12 and 2. So what I'm going to do is I'm going to write the first term, which is 8x squared. But instead of writing the middle term as negative 10x, I'm going to ungroup it and I'm going to write it as the sum of the two numbers that we came up with in step 2. So instead of writing negative 10x, I'm going to write negative 12x plus 2x, because remember, negative 12 plus 2 is negative 10. So this sums to negative 10x. So it's still equal, to the same expression that we have up here, and then minus 3. And now we have a polynomial in 4 terms, and we looked at those up here, right? We were factoring a polynomial with 4 terms by grouping. So we're going to continue factoring this using grouping. So what I'm going to do is I'm going to split this expression down the middle, and I'm going to factor the two groups. So 8x squared minus 12x, I can factor out a 4x. And now I'm going to be left with 8x squared divided by 4x, which is going to be 2x. And then negative 12x divided by 4x is a negative 3. And look at the 2x minus 3. The only thing that's common to a 2x and a minus 3 is a 1. So let's factor out a 1 and then divide each term by 1. So 2x divided by 1 is 2x. Negative 3 divided by 1 is negative 3. And now you see we have a common factor. It's the 2x minus 3. So I'm going to factor out the 2x minus 3. Whoops, that's backwards. So I'm going to factor out the 2x minus 3. And then my other factor, once I divide both these expressions by 2x minus 3, I'm going to be left with 4x plus 1. And that's going to be my factored form. So if I were to use my distributive property and multiply out, I would end up with 8x squared minus 10x plus minus 10x minus 3, which was the original in part A. So let's look at another one. Let's look at B. So for B now, 2x squared plus 5x minus 3, I have A is equal to 2, B is equal to 5, and C is equal to negative 3. So if I take A times C, I'm going to get 2 times negative 3, which is negative 6. So now I need to think of two numbers that multiply to negative 6, but are going to add to B, which is 5. So that's going to be a positive 6 and a negative 1, right? Because 6 times negative 1 is negative 6, but 6 plus a negative 1 is a positive 5. So now I'm going to rewrite my polynomial, but I'm going to replace the middle term with the sum of the 6 and the negative 1x. So look, I'm going to have 2x squared, but let's replace the 5x with a plus 6x and a minus 1x. And then don't forget the minus 3 at the end of the polynomial. So I ungrouped that middle term of a 5x. So now I have 4 terms. I have a polynomial with 4 terms, and we're going to factor it by grouping. So let's split this polynomial into 2 groups. So first, let's look at 2x squared plus 6x. I can factor out a 2x. Now 2x squared divided by 2x is going to be x. And now 6x divided by 2x is positive 3. And now I need to factor the negative 1x minus 3. The only common factor is 1, but I'm going to make it negative because the leading coefficient's negative. So I'm going to factor out a negative 1. Now divide both terms by negative 1. So a negative 1x divided by negative 1 is positive x. And then negative 3 divided by negative 1 is a positive 3. And I can factor out this term of an x, the common factor, x plus 3. So both expressions have a common factor of x plus 3. So let's factor out the x plus 3. That's going to be one factor. And now when I divide 2x times x plus 3, I'm just going to be left with 2x. Now divide the negative 1 times x plus 3 by x plus 3, and I'm going to be left with negative 1. So my factored form is going to be x plus 3 times 2x minus 1. So next we have another factoring method called the difference of two squares. This you guys should be familiar with also. You've definitely been exposed at some point or another to factoring a difference of two squares. So how do we identify if an expression is the difference of two squares? Well, the expression has to be a binomial and it has to have a difference, meaning subtraction. But the two terms that are being subtracted from one another have to be perfect square. So in other words, we have to have something squared minus something squared. So we write that as a squared minus b squared. So if I have something that's in the form a squared minus b squared, I can factor that as a plus b times a minus b. So let's do an example. So look at a, for example, 21. I have x squared minus 16. So I'm thinking, all right, my common factor is 1. That's not going to help me. And I do notice I have an x squared and I see a subtraction. So I'm thinking, okay, this could be difference of two squares. And then I look and I say, okay, 16 is a perfect square, right? If I rewrite this, this is the same thing as x squared minus 4 squared. So doesn't this look like a squared minus b squared, right? Think of x as a and 4 as b. And the way we factor that is we take a plus b and then we multiply that by a minus b. So we're going to take x plus 4 and then multiply that by x minus 4. And that would be my factored form for x squared minus 16, which is the difference of two squares. Let's look at b, which is x squared minus 81. So again, I can't factor out a GCF because the common factor is 1. I see I have a binomial. I see a difference. I see a squared term. So I'm thinking, okay, this could be difference of squares. And I see 81's a perfect square. So let's rewrite this. So this is the same thing as x squared minus 9 squared, right? Because 9 squared is 81. So look, here's like my a squared, and then think of 9 as your b, right? So I have x, which is a, right? So x squared minus my b squared, or 9 squared. So I'm going to factor that as a plus b times a minus b. So we're going to have x plus 9 and then x minus 9. And that would be my factored form. So let's try another one. C, again, it looks like I have perfect squares, right? I see 36, 25. I have an x squared. I see a difference. So let's rewrite this, right? Instead of 36, that's the same thing as 6 squared. So I have 6 squared times x squared. And then minus 25 could be rewritten as 5 squared. And really, there's no need to write 6 squared x squared. We could write that even more simply as 6x squared, right? We learned this in the first section with our exponent laws. So 6 squared x squared is the same thing as 6x squared. And then I have minus 5 squared. So look, I have a difference of two squares. Now think of a as the 6x, and then the b is the 5, right? So I have a squared minus b squared. So the way I'm going to factor that is a plus b, right? So 6x plus 5, and then times a, which is 6x, and then minus b, so minus 5. So my factored form is going to be 6x plus 5 times 6x minus 5. Let's do one more. So part D, I have 9x squared minus 49y squared. My greatest common factor is 1, so factoring out a GCF is not going to help here. But I do see I have a binomial. I have a difference, I have some squares, and then I see 9 and 49 are perfect squares, right? So this is making me think, all right, maybe this is difference of two squares. So let's rewrite this. So 9x squared could be rewritten as 3 squared times x squared, because 3 squared is 9. And then the square root of 49 is 7. So I could rewrite 49 as 7 squared. So this is 7 squared times y squared. And I could write that even more simply as 3x squared minus 7y squared. So now look, this looks like the form a squared minus b squared, where think of the 3x as your a and then the 7y as your b. So this is going to be equal to a plus b, 3x plus 7y, times a minus b, or 3x minus 7y. And that would be my factored form. Now, the last factoring method that I'm going to go over is the sum or difference of cubes. And actually, you know what? Before we get to the sum or difference of cubes, I just want to point something out. I'm just going to go to the whiteboard for a minute, because I don't want you to make this mistake. The difference of squares only works for the difference of two squares. So for example, if I said to factor, hold on a second. If I said to factor x squared plus 25, even though I could rewrite this as x squared plus 5 squared, right? I have two squares here. It's not a difference. You see how this is a sum? So this is not equal to x plus 5 times x minus 5. This only works if it's a difference. So x squared plus 25 is not factorable. We can't factor a sum of squares. So we also call it prime if it's not factorable. So I just wanted to point that out. So don't be so quick just because you see squares, right? If it's a sum, can't factor it. All right, so now let's go back to factoring the sum or difference of two cubes. We can factor a sum or a difference of cubes. Cube meaning to the third power. So if I have a sum of two cubes, let's say a to the third plus b to the third, I can factor that by taking a plus b and multiplying it by a squared minus ab plus b squared. That's the factored form of a to the third plus b to the third. I could also factor the difference of two cubes. So if I have two cubes and we take the difference, like a to the third minus b to the third, in factored form, that's going to be equal to a minus b times a squared plus ab plus b squared. So let's do an example. Example number 22, let's look at A. So I'm thinking to myself, all right, I have a binomial. My GCF is 1, so factoring out a GCF is really not going to help here. I see a sum and I see a cube, so I'm thinking, okay, this might be a sum of cubes. So let's try to rewrite the 27, right? The 27 I could rewrite as something to the third, right? 3 to the third. 3 times 3 is 9. 9 times 3 is 27. So look, I have a sum of cubes here. It looks just like a to the third plus b to the third. So think of x as the a and the 3 as the b. So let's plug in to this factoring form, right? So we're going to take a plus b. So this is going to be equal to x plus 3. And then we're going to multiply that by a squared. where a is x, so this is going to be x squared, minus a times b. A times b is going to be x times 3, or 3x, we would write it. And then plus b squared. So plus b, which is 3 squared. And we could simplify this, right? Because 3 squared is 9. So I could rewrite this as x plus 3 times x squared minus 3x plus 9. And that would be my factored form. So x to the third plus 27 can be rewritten as x plus 3 times x squared minus 3x plus 9. So let's look at B. Let's factor 125 x to the third minus 8. There's no GCF other than 1. So factoring out a GCF is not going to help me here. I see a difference. I see a cube. And I'm thinking, all right, difference of cubes maybe, right? So let's write 125 as something to the third, and let's try to rewrite 8 as something to the third. So what could I raise to the third to get 125? That's going to be 5, right? This is 5 to the third times x to the third. And 8 can be rewritten as 2 to the third. And I could even rewrite 5 to the third, x to the third more simply as 5x to the third. So we have 5x to the third minus 2 to the third. So now I have the proper form for a difference of cubes. Think of this as a to the third minus b to the third, where a is 5x and b is 2. And we could plug into the factoring form for difference of 2 cubes. So this is going to be equal to a minus b. So I'm going to take 5x minus 2. And then I'm going to multiply that by a squared, where a is 5x. So this is going to be 5x squared plus a times b. So plus 5x, which is a, times b, which is 2. And then plus b squared. So then I'm going to add 2, which is b squared. And we could simplify that, right? Like I could write, well, let's bring down the 5x minus 2. And then 5x squared is 25x squared. 5x times 2 is 10x, so plus 10x. And then plus 2 squared, which is 4. So my factored form is going to be 5x minus 2 times 25x squared plus 10x plus 4. So that's how we factor sum or a difference of cubes. And that's the last factoring method that we're going to go over. So let's just list our factoring methods then at this point. So we have factoring out a GCF. We have grouping. We have factoring a polynomial in the form x squared plus bx plus c. We can use the AC method to factor ax squared plus bx plus c. We have difference of squares. And we also have the sum or difference of cubes. So these are the different factoring methods really that we did since the beginning of this lecture. I did all different examples. So what I wanted to do at the end of this lesson is condense this and kind of rewrite this so that let's kind of have a process in our mind when we go to factor. So what steps should we follow when we factor? So that's what I have here, steps to follow when we're factoring. So the first thing that I would always try to do, try and factor out a GCF first. If there is a GCF, then factor it out. And then look at it and see if the result could be factored further. If there is no GCF other than 1, let's go to step 2, because just because there's not a GCF, it doesn't mean that it's not factorable. Then ask yourself, okay, how many terms does the polynomial have? Does it have 4 terms, 3 terms, 2 terms? So if it has 4 terms, then what we're going to do is go to step 3. And for a polynomial with 4 terms, we said we factor by grouping. But let's say my polynomial has 3 terms. Step 4 says for a trinomial, identify what form it takes on. Is it in the form x squared plus bx plus c, or is it in the form ax squared plus bx plus c? So you would use the appropriate method to factor a trinomial. If your polynomial has 2 terms, we would go to step 5, which is maybe it's the difference of 2 squares, or maybe it's the sum or difference of cubes. And if it is, you would follow the appropriate factoring method. And remember what we said, if you can't factor a polynomial at all, we just say it's prime because it's not factorable. So to wrap up, let's just do 2 more examples and let's follow that guide that I just went over above. So look at number 23. So let's factor 3x to the third minus 30x squared plus 75x. So the first thing I would try and do is factor out a GCF. So I'm looking at these 3 terms and I see that they all have a 3 in common. So I'm going to factor out a 3. And they also all have an x in common, right? We have an x to the third, an x squared, and an x. So I'm going to factor out an x. So now divide each one of the terms by 3x. So 3x to the third divided by 3x is going to be x squared. Negative 30x squared divided by 3x is going to be negative 10x. And then 75x divided by 3x is going to be a positive 25. But just because you're able to factor doesn't necessarily mean you're done factoring. Look at your result and see if one of the factors could be factored even more. So I have a 3x times an x squared minus 10x plus 25. And I'm thinking, I have a trinomial here, right? In the form x squared plus bx plus c. Can that be factored even further? If it could, then there would have to be 2 numbers that multiply to 25 that add up to negative 10. And I'm thinking a negative 5 times a negative 5, right? Negative 5 times negative 5 is positive 25, and negative 5 plus negative 5 is negative 10. So I can factor that further. So this is going to be equal to 3x, because that factor is not going anywhere, but I can further factor this trinomial. And we said, all right, a negative 5 and a negative 5, right? Multiply to positive 25, and a negative 5 and a negative 5 add up to negative 10. Now we're fully factored. And you can also write this, since it's x minus 5 times x minus 5, we could just write that as 3x times x minus 5 squared, right? Because there's 2 of them that we're multiplying. And then let's do one more. Let's look at B. So I have 5m squared minus 20. Always start by seeing if you could factor out a GCF. In this case, my common factor is 5. So I'm going to factor out a 5. And then my other factor, I'm going to be left with m squared minus 4. Now ask yourself, can you further factor m squared minus 4? And I'm thinking, yes, right? I'm seeing a difference of 2 squares, right? M squared minus 4, which is 2 squared. So this can be factored even further, right? I'm going to have m plus 2 times m minus 2 because I have a difference of squares. So my final factored answer is going to be 5 times m plus 2 times m minus 2. So that wraps up the factoring section. The last section that we have to cover in the prerequisite chapter is P6 rational expressions, and I'll do that in the next video.